Okay, here we go. Little Mr. Bierschbach teaching today. Instead of having just Sailman Can do it all for me. Suppose I better do a little bit of it. All right. How do we find relative minimums? Well, good question. Yeah. To find relative minimums, we have to take the what of this. First derivative. If we take the first derivative to get 3x squared minus 6x minus 4, we set the first derivative equal to 0. Okay. When we take the derivative, it's minus 4x, not minus 6x. You are correct. All right. All right. So then, if we factor this, some of you don't want to factor that, do you? You'd rather do the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. 16 plus 48 is 64, right? Which is 4 plus or minus 8 over 6. 4 plus 8 is 12 over 6 is 2. 4 minus 8 is negative 8 over 6 is negative 4/3. Okay? So for what value of x has a relative?
4 minus 8 is negative 4 over 6 is negative 2/3.
Negative 2/3. Yeah.
I was gonna say.
I got it.
All right. So are we good with these two answers? Yeah. Okay. So then you check what's going on either side of them. So what you got going on is you got a 2 here, or a negative 2/3 here, and a 2 here. So what's the easiest number to check in between them? 0. So what's going on at 0? So if you stick 0 into here, we get a negative 4. So it's a negative answer here. So what's the graph doing? It's going down here. After 2, what do you think it's going to be doing? Going up. So then here, since it's not a double root, it should be going up before it gets there. Just to check, we could throw a negative 10 in here. Negative 10 is 100. Square negative 10, it's 100. So this is like 300 plus 40 minus 4 is definitely positive. So it's positive, negative, positive. So where's the max at? At negative 2/3, because it's up here somewhere. The graph is going up, then down, so there's got to be a max up here somewhere. Where's the min going to be at? 2, somewhere down here. For what value of x does it have a relative minimum? That's the process. Okay? Now, Aspen's going, why the heck can't I graph this and just look at the graph and see and find the minimum? Yeah, you can. But guess what? On the AP test, this will be a non-calculator question because there's 4 sections of the AP test. 2 of them are calculator you can use. 2 of them are non-calculator. You can't use your calculator. So if this is a non-calculator one, this you have to do by hand, and this is the process. Okay? The more work you show, the better you have a chance of getting points. Now, on the multiple choice, no. Multiple choice, you don't have to show any work. You just, if this would be one of the open-ended ones, and you will talk more about that come March. March and April, we spend time talking about the test. We just got to get all this stuff down before March and April, so then when we start working through the tests, that we understand what's going on. But like I said, 2 sections are non-calculator, so if you are just banking on calculator for every one of these, when you get to the test, you're not going to know what's going on. Okay? So you got to know the process.
Hold on, does that mean I have to do negative 4 times 3 times negative 4 in my head?
Yes. Yeah. Or you could factor it. I mean, this factors into 3x minus 2 times 3x, or 3x plus 2 times x minus 2, and you can find it that way too, if you're good at factoring. Okay. Okay, so this is the derivative now. See, the original problem, first problem, this was a function, and we had to take the derivative. Let's say we were given the derivative. How many points have a relative minimum? Okay, how do we check this? Set these to 0, so you have 0, 1, and negative 2 as your points, right? So on your number line, you have 0, 1, negative 2 as your points. Now, we have to figure out what's going on the left side of negative 2. So let's put in like negative 10 to this function. Negative 10 would make 100 here, a negative here, and a negative here. What's a positive times a negative times a negative? Positive. So we're positive, so the graph is shooting up there. Okay? In between here is like negative 1, right? So if we put negative 1 in here, that makes a positive there, a negative here, and a positive here. What's a positive times a negative times positive? Negative. So the graph is going down here. So if we put 1/2 in, 1/2 squared is a positive number. A negative number here and a positive number here. It is negative. It doesn't change. Just because you hit a point, it doesn't automatically change every time. And then after this, if you put a big number in, it's going to be positive. Okay, so what the graph is doing is it's going up, coming down, flattening out, and continuing to go down, and then go up. Okay, so 0 is not a minimum or a maximum. Okay, it's just a turning point, you could say. So where is our minimum going to be located at? Not in between 0 and 1, right at 1. Okay, right at 1, because 1 is where it changes from going negative to going positive. Now, quick little thing, quick little hint here. Okay, if it's squared, it's not going to change signs. If it's an even exponent, it's not going to change signs. If it's an odd exponent, it is going to change signs. Okay, so the first power, it should change. Even should not change. Okay, got it? So that's how to find relative minimums. Okay, now we go to absolute minimums. Now, it's a closed interval from -6 to 2. So we have to use check values and we have to solve this. Now, what's the first derivative of this? 3x squared plus 12x. Set it equals 0. Take out a 3x and you get x plus 4. So x equals 0 and x equals -4. Are they both within this? Yep. So you have checkpoints of -6. Oh, I don't want to. You have checkpoints of -6, -4, 0, and 2. Now what we're going to do is it says what is the absolute minimum. So what I'm going to do is I'm going to take these points and put them into the original function to find the absolute lowest number. And that'll be your absolute minimum. Now, it could be one of the endpoints, or it could be one of the points in the middle. Okay? So if you stick in -6 and do the math, stick in -4, do the math, and so on. Can you do that? I don't want to waste your time by plugging in numbers. Okay? But you have to do the endpoints too, because the endpoints could be part of the absolute minimum. We're finding the absolute minimum, so we want to find the absolute lowest number. What? We've been putting it in the derivative to find out if it's increasing or decreasing. But now we want to find where the absolute lowest number is. So if we want to find because the absolute lowest number could be one of the endpoints, or it could be one of these points where there's a relative min or relative max. So if you just put it in there, then you figure it out. Okay? All right, the absolute maximum of this. If I was you guys, I'd be graphing this one. But I don't know if this would be on the you can't use the graphing calculator section or not. So how you do it by the non-graphing calculator is you have to take the derivative of this. How do we take the derivative of this? It'd be x times the first derivative of this, which would be negative 2e to the negative 2x plus e to the negative 2x times the first derivative of the x, which is 1. So if we set this equal to 0, we factor out the e to the negative 2x, you get negative 2x plus 1 equals 0. Okay? Where does e to the 2x equal 0 at? E to the what equals 0? E to the 0 power, right? No, nothing equals 0 for e, right? Yeah, so this one we don't even worry about equaling 0. So we set this equal to 0, move the 2x over, divide by 2, x equals 1/2. Okay? X equals 1/2. So is x equals 1/2 a minimum or a maximum? Okay, how do we check that? Put it back into the first derivative to see if it's a min or, wait, no. Put a number beside it, each side of it, into the first derivative. So if we go like 1/4 into this, okay? Figure out what it is, put in, yeah, actually, let's go on the other side of it. Let's put in a 1 into this, because that's easier. So you get, if you put in a 0, you get e to the, oh, you could, I suppose. 0 times this, and e to the 0 is 1, so you get 1, right? Yeah. So if you put in a 0, it's going up before you get to that. Let's put in a 1 now, and so you get 1, and then negative, so it's 1 times negative 2 e to the negative second plus e to the negative second. So negative 2 plus 1 is negative 1 e to the negative second. Somebody calculate out what is negative 1 times e to the negative second, or negative 1 e to the negative second power. I'm guessing it's going to be a negative number. Negative 1 e to the negative second. So e to the negative is just a number, a positive number, and then multiplying by negative 1 makes it negative. So it's going to be going down that. So this is a max. So what's the absolute minimum of f? Oh, absolute max?
Yeah.
What is the absolute max? Well, it happens when x equals 1/2. You stick 1/2 into this formula. So it's 1/2 e to the negative first. That's where that's what the absolute max would be. So 1/2e. There you go. That's what the absolute max is. Okay. All right. Absolute minimum of this. Do we want to do this or are we good? We're good. Okay. We're good with that. We got it. All right. I'll just let you guys get going.